Okay, before the break, we were discussing the methods for mode choice, and we came to the trip interchange models. And one of the trip interchange models was using the QRS system, the QRS method, which depends upon the impedance. The other one is the logit model. In logit model, basically, it is similar to impedance. It works on a thing which is similar to impedance, but it is the inverse of impedance. Impedance is the weighted summation of things you don't like about a mode. For example, travel time, access time, cost. Utility. So logit model depends upon utility of the mode. So utility is the inverse of the impedance, things which you like about the mode. Okay, so it's basically the inverse of impedance, and for each mode, then you calculate the utility function, which you can see here. Okay, where a is the coefficients of the equation, a are the coefficients of the equation. Okay, so these are the constant values, and x is basically the parameter for each mode. Okay, so for example, so you can see the summation here as well. So for example, you collected 4 things about each mode: cost, time, parking cost, and speed. Okay, 4 things. So there will be 4 x values here: x1, x2, x3, and x4. Okay, and each one will be the time and the cost and the parking cost and the speed and so on. Okay, and with each value there will be a coefficient. Okay, there will be a coefficient, and the summation of these will give you the utility function. So in the utility function, if a is positive for a mode, that means that attribute affects the utility positively. For example, a can be positive for speed. If you have an x with the speed, or if you have a variable with the speed and you put it in the model, then a may be positive. Similarly, if a is negative for a variable, that means that variable affects the utility in a negative way. So for example, cost. So if a for cost can be negative, normally it is negative. Okay, so you calculate the utility function. Okay, you calculate the utility function, and then for each mode. So if you have 2 modes, you will have 2 utility functions. Okay, like that they are showing here. Again, assuming that we have 2 modes, auto and transit, then if you want to calculate the probability of each mode, it will be calculated in this manner. Okay, so last time when I showed you the utility equation coming from Statistica, so Statistica is basically giving you this equation. Then if you want to calculate the probability of the autonomous vehicle or car or any other mode, then you put it into this equation. Okay, so this equation will give you the probability of auto, and again, if you know the probability of using the auto mode, then the remaining will be the probability of using the transit mode. So the probability of using car is, let's say, 60%, then probability of using transit is 40%. It's very obvious. Okay, and one more thing, like I said, if a is negative, that means that variable is affecting the utility in a negative way, and then that variable will be called as disutility. Disutility. Okay, so the variable which has a positive coefficient is the utility variable, and the variable has negative coefficient, it is the disutility value. Okay, so we are giving the utility functions of auto and transit. Okay, you can see it here. T1 is travel time, T2 is waiting time, C is cost, and both of them are available in the utility functions for auto and transit. And the characteristics of each mode is given here, and then we need to calculate the probability with these values of using the auto or the transit mode for each traveler. Okay, so going back. Yeah. Okay, so utility for auto minus 0.46. Okay, so 0.46 is a constant. It is not multiplied with anything. Okay, intercept. Okay, so it doesn't mean anything. It can be positive, it can be negative. Okay, but you can see T1 travel time. It has a negative coefficient, so that means travel time is a disutility value. Okay, so 0.35 into T1. T1 for auto is 20. Then T2 is waiting time. Waiting time for auto is 8. Again, that can be the waiting time for coming from parking or something. Access time basically. So 0.08 into T2, which is 8. And then minus 0.005 cost, which is 320. Okay, so give me this value, and then the utility for transit minus 0.07 minus 0.05 T1, which is 30 minus 0.15 T2, which is 6 minus 0.005 C is 100 Okay, so give me these values for auto and transit. Yes, anyone? So while you're calculating the values, let me explain the difference between the previous model and this one, between the impedance and utility. Now you can see in impedance, we had time and access time and cost, and here we have the same variables. Okay, but in impedance, they were taken as a positive function with a positive coefficient. All of them had positive coefficient. In utility, they have negative coefficient. Okay, because utility meaning the benefit. So these things are not benefit, these are disbenefits, disutilities, so they become negative. Okay, so the main difference between the impedance term and the utility term is their meaning. Impedance means the resistance, the friction. Okay, the disadvantage, and utility means the advantage which you are getting from the model, from the mode. Okay, so all these things which for the positive in impedance became negative in utility. Okay, secondly, the difference is with the function as well. Did you calculate the values?
Doctor, first one minus 9.7.
Minus 9.7. Okay, there will be minus, both of them will be minus.
Second one minus 2.97.
Okay, now if you want the utility for the probability of using the car, it will be the utility of car, which is sorry, it will be e to the power. Okay, utility of car, which is minus 9.7 divided by so e to the power minus 2.97. Okay, give me this value.
Doctor, very small value.
Sorry?
Very small. 0.001193.
Let me check.
Why did you put square, doctor?
What?
No need to the power, doctor. Sine power.
Ah, okay, okay, yeah, yeah. And these values are correct, right? Yeah. Okay, so 0.00 means 0.1% basically, right? 0.1%. Okay, so the remaining is 99.9%. Auto on the top, right? Auto 9.7 on top. 28 and 320. 28 and 320, yeah. Yeah, okay. What can we do? Okay, so 0.1%. The remaining is the probability of using the transit then. Okay. Give me a second. Okay, now the word logit, because you may hear it in some other functions as well. Logit is basically a function. Okay, the term logit, when we say logit model is basically this function. This function is what we call as logit model. Okay, make any mistakes, it's all in minutes. I think 100. I think the units. I think they should be correct. Anyways, so the important point was the procedure. Anyway, so the thing is that whenever you are taking the exponential, the ratio of the exponentials, we call it the logit function. Okay, this is why we call it the logit model. Okay, so logit model can be applied to anything. So instead of utilities, you can have any values here. So whenever you are taking the ratio of the exponentials like this, we call it the logit model, the logit function. Okay, so logit function is basically used here, and this is why we call it the logit model. Okay. Okay, so in the previous equation, in the previous example, you saw the utility function is already given here. Okay, in your term project, I said you can use Statistica to calculate the utility function. Statistica will give you these coefficients. It will give you these coefficients. Okay, and then you already have the cost and the time and everything. So you can borrow a utility function as well. This is the commonly applied utility function. B into in-vehicle cost plus C into out-of-vehicle cost and D into, out-of-vehicle travel time, in-vehicle travel time, and D into cost. Okay, so this is what we call as a borrowed utility function. Why borrowed? Because the coefficient, the variables are fixed. We are using three variables: in-vehicle travel time, out-of-vehicle travel time, and cost. So these are fixed, three fixed variables. Okay, and then we need three coefficients, and you can see there's no constant here. There's no constant here. Usually in the utility function there's a constant as well. Okay, so borrowed utility function means you take the three most common factors which can affect the mode choice, which is travel time, in-vehicle travel time, out-of-vehicle travel time, and cost. Okay, and then you need to find out B, C, and D. So the value of B and C, as per NCHRP report, is fixed, 0.025 and 0.05. Okay, So NCHIB is National Council for Highway Research Program. Okay, National Council for Highway Research Program. So BNC values are taken from a lot of research. Okay, and then if you need the value of D, so D can be calculated in this manner. Okay, so you need the value of B, which is 0.025, 1248, which is the constant. Okay, which converts the dollars into cents per minute. Okay, then we have TVP, the ratio of 1 hour of travel time divided by hourly employment rate. Okay, like how much money you are earning per hour. Okay, so value of 1 hour of travel time divided by hourly employment rate. Okay, and if you don't have any other data, then TVP can be taken as 0.3. Okay, TVP can be taken as 0.3, and AI is the average annual household income for that zone, for that region. Okay, so you have the income is in dollars. Okay, and you want the cost in cents, so that's why we have the factor of 1248, so that the dollar per year is converted to cents per minute. 1248 is converting dollars per year to cents per minute. Okay, so TVP, value of 1 hour of travel time divided by hourly employment rate, again for that zone, and AI is the average household income for that zone, and B and C, you can take the standard values. Okay, so we have a transit authority who want to find out the total travelers in a corridor. Corridor means a route, okay, that will shift from auto to the new proposed bus line. So they are starting a new bus line, and they want to see how many people will shift from auto to their line, and local data is unavailable because the bus line is not operating. Okay, so they will use the borrowed utility values. Okay, values that I showed you. The key factors are time and cost. Average household income for that zone is $60,000. Okay, TVP 0.3. Waiting time is perceived to be twice as long as the riding time. Okay. So we need the system times and cost. System times and cost values are given here. Okay. Find out the proportion of persons who will use the new bus line. Okay, so in vehicle travel time, out of vehicle travel time, and the cost in cents is given. Okay, so first of all, we calculate the D value. Okay, so B will be taken as 0.025, 1248, TVP is 0.3, and average income is 60,000. What is it? And then after that, you can apply the function. $30 into 6 into 5. Okay, and the cost is 100 into which you will give me. Okay, and that for transit, the factors will remain the same. Okay, so in the case of borrowed utility function, the factors for auto and transit are the same. Here you saw the factors were different. When you develop the utility equation yourself, the factors can be different. So instead of 30, 20, sorry, this is for transit then. This is for transit. The auto
Doctor,
is
D equals 0.017.
0.017, okay. And then we have okay. How much is the utility here?
Uh, 2.78. 2.53. No, I have mistaken. Second one. There's 320.
Yeah.
$6.44.
Okay. Then if you calculate the utility, e to the power 6.44 divided by power 6.44 plus e to the power 2.78.
$0.97.
Okay, so 0.97 basically means 97% people will take auto, the remaining 3% will take transit. Okay. Okay, referring to the previous example, let's say upon inaugurating the bus service, the percentage of travelers that use the new bus service is actually 65%. Okay, so yeah. Follow-up surveys confirm that the coefficient B, C, and D, which were used to estimate the previous total, they were correct. So the value of B, C, and D were correct. Okay, the values of B, C, and D are correct. Then what is the difference here? Surveys suggest that what? Beyond time and cost for the bus, using the bus influenced by the availability of laptop outlets at each seat. So at each seat, they are providing complimentary drink, a beverage, and they have a laptop outlet because of which the people are shifting more towards the bus service. So what they have done is they have introduced a more specific coefficient, a constant. So if you see here, this equation did not have any constant. Okay, so they said we should introduce a constant here. Okay, so that constant is So you can either add a value to the utility of the bus, or you can subtract a value from the utility of the bus. Oh, sorry, from the utility of the car. Okay, because this one has a positive effect on the use of the bus service. So you can calculate a constant and add it to the utility function of the bus, or you can calculate the same value and subtract it from the utility of the car. Here they are adding this constant in the utility of the bus. Okay, but let me check something here. Why are our values not matching? I just want to check that our values are not matching with the values which are given in the book for both the examples. Doing this one. Okay. So here, okay, this is a calculation mistake, no problem. There's a 0.08 into 6 and 100 into, okay, fine, this is a calculation mistake. So this should be 11.55. The calculations are correct. And then you will get 86%. Now what happened here? Ah, these are negative. Sorry for that. This is my mistake then. These coefficients are negative. All these coefficients are negative. Okay, this is my mistake. Okay, you can correct the mistake in the slides. Okay, this should be minus. All of them are minus. Okay, correct it in the slides. It should be minus. B, C, and D should be minus. And these values are, the values are the same, right? 20 and 8, and this is, yeah. .025, and then we have 30 and 6 and 100. Where is it? 30 and 6 and 100, yeah. 50s. Okay, so this was a little bit of a mistake in the coefficients. Okay, you can correct in the slide. Where was I? Yeah. Okay. Now the thing is, we have something. Okay, and this is basically the use of the constant. Okay, the mode specific constant which we were having in the initial function. Okay, so you can see 0.46. What is 0.46? Then you can see here 0.07 as well. This is what we call as mode specific constant. Mode specific constant. In the utility standard utility function which we were using, these constants are not there. Okay, what is the purpose of having these constants? If you have factors for which the effect cannot be or for which the value cannot be calculated. For example, they are saying the bus company is providing a beverage to each passenger. Okay, then what is the effect of that beverage on the passenger number of passengers? We cannot quantify it. We do not know it. Okay, that each each drink is increasing how many passengers, we don't know. Okay, similarly the laptop outlets, again something which we cannot quantify in terms of the effect on the passenger. We don't know how many passengers are actually coming because of the outlet. Okay, the laptop outlet, so we don't know. So because of these things we introduce a constant term. Okay, now in this example they are saying that these two factors, the laptop outlet and the beverage service, is basically increasing the passengers percentage from 55% to 65%. Without these two services, the standard utility function is giving you around 56% passengers, around 56% passengers. So what is the effect of this utility, this laptop and beverage service? To calculate it, what we will do, you take the equation, for example, probability of the bus service. Okay, and you, like I said, you have two options. Either you add a constant to the bus equation, or either you subtract a constant from the car equation. Okay, in this case they are saying we will add a constant to the bus equation. Okay, now what should be the value of the constant? What should be the value of the constant? We know that 65% people are choosing the bus service actually. Okay, so what we will do, this is the utility of the bus from the traditional utility function, plus let's say A. Now let's say we don't know A. Okay, and then you have the denominator as well. Again it will come as A here as well. Okay, but we know this whole term should be equal to 0.65, 65%. Okay, so since we know the answer and there is one unknown in the equation, so then you can calculate the value of A. Okay, so this is how they calculate the value of the mode specific constant. Okay, so mode specific constant is added to the utility function for things which you cannot easily quantify, or for things for which you do not know the exact effect on the mode choice. How to find it out? You use the standard utility function without the constant, calculate the percentage, and then you compare it with the actual percentage, and then you can calculate the constant like they are shown here. So let's say 0.38885, you replace it with A and put this whole term equal to 0.65. Then you calculate the value of A. Okay, and obviously if you know how to solve the equation exponential, you can use that. Or like me, if you are somebody like me who doesn't like to solve complex equations, just use trial and error. Okay, just use trial and error. Okay, so for example, one of the parameters have changed. Okay, so you had utility function. Using that utility function, you calculate the probability of mode I. You calculated the probability of mode I. Okay, now let's say the bus service has increased their speed, so their in-vehicle travel time is now less. So what will be the new utility of the mode of the bus service? Okay, what will be the new utility of the bus service? Okay, for that we have this equation. Okay, this is similar to the equation which we are already using, but instead of U, we are using delta U. So what is delta U? The difference between the old utility value and the new utility value. Okay, so old utility value will be with the old values and new will be with the new values. Okay, so for example, I think there's an example here. Yeah, let's say the equation which we considered previously, they are considering investment in the signal preemption for transit services. So whenever the transit vehicle will come to the signal will become green for them, or it will give priority to the side which has the transit vehicle. So in that case, obviously their time will decrease. The in-vehicle travel time will decrease. So it will go from 30 to 25 minutes. It will reduce from 30 to 25 minutes. All other service amenities will remain the same. Determine the percentage of travelers who will use a bus service if this investment is made. Okay. Now they are talking about example 12.12, this one. Okay. So the utility of the bus is this one. Okay, 0.3885 constant is already added. Okay, so if I come here, the utility of the bus is this one. And then I add 0.3885 here, the constant. How much is this? 0.3885, right? Yeah. How much is this? I will call it the old one. How much is this value? So minus 1.454 plus 0.3885. How much? And then the new one will be calculated by just changing the value of in-vehicle travel time. So this will become, they are saying 25. So give me both these values. Yes. That's 2.36. Does it make sense? Minus 1.454. 1.54 plus 0.385. 1.8425. This factor will not come here. Yeah, it will come. So minus 5 into 0.025 minus 6, 2.05, 0.17 into 100 plus 0.35 minus minus 0.2. 0.05. And this and this. Point. Minus 25 into 0.025. 6 into 0.05. Double zero. Fine. Okay, now if you take delta u new minus old minus 0.7065 minus again 1.0655 359. Okay, going back to the equation we have. So the old, which is 65%, into this, into so only the function for car is changing. So for the sorry, only the parameter for bus is changing. Okay, in this case, the bus service is changing. So for the car, delta u will remain 0. For car, delta u will remain 0. Okay, so the old utility is the old probability is 0.65. To calculate the new probability, so 0.65 multiplied by the e power delta u, which is 0.359, divided by okay, so probability of was again the e to the power 0.359 9 plus the probability for car 35. So 65 is for bus and 35 is for car. And then it will be multiplied by e to the power 0, no difference. Okay, so if I calculate this value here, 5 to exponential 359 divided by 0.65 into exponential 0.359 0.35 0. %, basically. Okay, so it was 65%. With the change in parameters, it will go to 73%. Okay, so this is how you can calculate the change in the probability. Okay, and you can do the same thing. You can do the same thing by calculating the probability from the scratch again. Okay, so you use the same method which we did here, but the utility for transit will be calculated using 25 instead of 30, and then you will use the probability like this without the difference. Okay, but the utility function should be only the new one for the transit as well as the auto. For both of them, you will only use a new utility functions. Okay, but if you want to use this equation with the difference of the utilities, then this is the equation for that. Okay, so there are two methods by which you can calculate the effect of change in parameter. You calculate the probability with the old parameters and then calculate with the new parameters. Okay, using two different iterations completely together, completely separately. So utility of transit using 25, then probability calculated, then utility of transit using 30, and then you calculate the probability and then you take the difference. Otherwise, you can calculate it using this, where we are using the difference of the utility functions. The difference of the utility functions. Okay. Now, how do we calculate the utility function, the coefficients, the value of A, B, and C? How do we do it? There are software packages, like I showed you in the last lecture, Statistica, which can do it for you. They are mentioning two more here, SAS, okay, the statistical something, okay, and then we have A-Logit, which is all logit model. So these are two softwares which can help you to calculate the probability of, the utility functions, the coefficients of the utility functions, okay. And the method which they use is known as maximum likelihood method, maximum likelihood estimation method. Okay, I can explain the method. Okay, and I've already showed you how to do it in the Statistica software in the last lecture, the end. Okay, and as I said, if you have any problems, you can let me know, and you can show me your data and I can tell you what to do. Okay, so how this is applied, how maximum likelihood method is applied to calculate the coefficients A, B, C, and D. We take this example. A regional transportation agency wishes to calibrate utility functions, which you can use in logit model. They have three choices now. You can see three choices. Earlier we were doing it all for two choices. Okay, so now we have 3 choices, so the number of choices can increase. Survey data, they collected data from how many people? A, B, C, D, E, F. So 7 people. 1, 2, 3, 4, 5, 6, 7. 7 people. Okay, and from each person, they found their time if they use the auto mode or the bus mode or the railway mode. Okay, so for that particular person to go from his origin to destination, how much time it would have taken to go by auto mode, bus mode, and railway mode. Okay, and then considering all these 3 timings, which mode did he choose eventually? So this person A, in order to go from his origin to destination, it would have taken 10 minutes by auto, 13 minutes by bus, and 15 minutes by railway. And in the end, from all these 3 modes, he chose auto. Okay, for person B, same thing, but you can see for person B, the auto time is higher, but still he chose auto. The time to go by car from his origin to destination is higher than bus and railway, but still he chose the auto mode. Okay, so like I said, it depends upon person to person as well, and the system characteristics and everything. So, so in this equation, there's only one variable, which is the time. And so we want to apply maximum likelihood estimation to find out the coefficient of that variable. Okay, so like in the previous equation, this equation we had 3 variables, right? In vehicle time, out of vehicle time, and cost. But now we are just reducing the equation to this, and now we want to know the value of B. Okay, and this is just to explain the method of applying maximum likelihood estimation. Okay, how to calculate the coefficient using maximum likelihood estimation. Okay, and as I have mentioned, we cannot, if you try to do it manually, it will take a lot of time. Okay, so this is the utility function. B equals, U equals utility equals B into vehicle travel time. Okay, now let's say respondent A selected auto. We know respondent number A selected auto. Okay, then the likelihood, the maximum likelihood for respondent A is the probability that he will choose auto. Okay, maximum likelihood is defined as the probability of the mode which he has actually chosen. So respondent A chose what? Auto mode. Okay, so the maximum likelihood for respondent A is calculated as the probability of choosing the auto mode, whatever the probability is. Okay, because we cannot calculate the probability because we don't know the value of B yet. Okay, we don't know the probability of B yet. Okay, the probability of selecting the auto mode for respondent A can be calculated, let's say, in this manner. So you can see here B is unknown. Okay, so what is B? What is 10 travel time of the auto mode? Okay, so this is the probability function, right? The probability function, the logic function which we have been using. So for respondent A, if you want to calculate the probability of selecting A, then this is how you calculate it. Okay, exponential to the power utility of auto divided by summation of all exponentials. Okay, so summation of all exponential including exponential to the utility of auto, so B into 10, the time of auto, then exponential to the power B into 13, the time of bus, then exponential to the power B into 15, 15 is the time of railway. Okay, so this equation will give you the probability of selecting the auto mode. Okay, and auto mode is the actual mode he has chosen. So this is the maximum likelihood for person A. Okay, so maximum likelihood for each individual is the probability of the mode which he has actually chosen. Okay, so for respondent A, it will be the probability for choosing auto. If I go back, for respondent C, it will be the probability of choosing rail. It will be the probability of choosing rail. Okay, so if I come here and if I develop the same equation for respondent C, then E of railway will go in the numerator and all these will go in the denominator. Okay, so if I want to write, for example, the maximum likelihood for person C, the person C has chosen railway, then E to the power B What is the time for railway for him? 20. Okay, and again then e to the power b into 35, which is the auto mode. B into 32, which is for bus. Then e to the power into the railway time, okay, which is b into 20. This will be the maximum likelihood for person C. Okay, why? Because he has chosen the railway mode. So railway, the exponential of the railway utility will come in the numerator, and the summation of other utilities will go, exponential of the other utilities will go in the denominator. Okay, so for each person you will calculate the likelihood. Okay, and obviously by calculate I mean you will write the equation of the likelihood, and that will, in that equation b will be unknown. B will be unknown. Okay, now the maximum likelihood is or the likelihood for the entire data set is the product of the likelihoods of all the respondents. So you have the likelihood of A and B and C and D for all respondents. You have 7 respondents, so you will have 7 values of the likelihood. You multiply all of them, you will get the likelihood of the entire data set. Okay. Now obviously it will be a very complicated equation with lots of unknowns and so on. Okay. In this equation we are only considering one, though there can be lots of unknowns. So what you will do is you will try different values of B, and you will plot a graph like this. Okay, and the value of B at which the graph goes to maximum, you will take that value of B. Okay, so you will try the value of B as minus 0.5, minus 0.45, minus 5, and so on, and you will keep on calculating the L values, and then you will plot it. And the B value where you get the maximum L value, that will be the final B value. Okay, so in this equation, you will put the likelihoods of all the respondents, and then you will try different values of B, and the value of B where it goes to maximum, you will take that as the final value. Okay. Then the last step of the travel demand forecasting model is a traffic assignment. In traffic assignment, you are trying to calculate the number of trips for each street on each highway and each street. Okay. If you take the summation of the traffic assignment stage, then you will have the total number of trips on the entire network. Okay, or you will have the average daily traffic on the entire network. Okay, to calculate, to do the traffic assignment, we need the following data. We need the number of trips from one zone to another zone, which is the result of the trip distribution. We need the available data of the highway and the transit routes. We need the travel time for each route. We need a decision rule or algorithm that explains how the motorists are choosing the route. Okay, so what is their basis of the choice? Okay, and we need the external trips which were not part of the previous steps. The external trips which are coming from some other area. So these are still the people on the network, but they were not part of the same area. So they came from somewhere else. So we need how many trips are external trips as well. To do traffic assignment, there are 3 approaches: divergent curves, minimum path, and minimum time path with capacity constraint. Okay, so minimum time path and minimum time path with capacity constraint. They are same method with a small variation. Okay, in divergent curve, the method is similar to mode choice curve, like we had the mode choice curve using the the urban travel factor. Okay, it's the same way. So you have a percentage of people who will select a particular mode, and you will have the travel time ratio between the 2 routes. Okay, so you have 2 routes available to go from, let's say, X to Y, from point 1 to point 2. There are 2 routes available. Okay, and obviously if you increase the number of trips on one route, it will affect its travel time, right? So for example, I have 100 trips. Out of those 100, if 60 go from A and 40 go from B, then the travel time of A will be according to these 60 vehicles, and travel time of B will be according to those 40 vehicles. Okay, if I change the number of vehicles, okay, so let's say now out of 100, 30 are going from A and 70 are going from B. So that means what? The travel time of A will become less and the travel time of B will become higher. Okay, so you take any of the routes. So let's say they have taken route B here. Okay, they have taken route B here. So when the percentage of trips on route B increase, then the travel time for both the routes will change, right? So then what will be their ratio? So when there are 0 trips going from B, what will be the ratio of travel time on route A upon travel time on route B? So 0 trips from B means what? All people are going from route A. Okay, everybody is going from route A. So then you change from 0 to let's say 25%, and then you recalculate the ratio, then 0 to 50%, recalculate the ratio, and so on and so forth. Okay, and then you assume any value, and on the basis of ratio of the travel time, you can know how many people will go from route B, and then obviously the remaining will go from route A. So in this case, instead of travel time, you can take the ratio of the cost as well. If both routes have different costs, one has a toll plaza, they are taking tax or something there, you can take the ratio of the cost as well. Then we have minimum path algorithm, which is the most widely used, the most commonly used, okay, because it is more accurate and it is easier to understand as well. Minimum path means people will go from one zone to another zone using the least travel time path, the path which gives them the least travel time, okay, the quickest path, okay. So we use an approach which is known as a skim tree approach, okay. And in a skim tree, basically you plot a tree from one zone to the other zone, and you connect the dots, you connect the branches which have the least travel time, So basically in minimum path algorithm, you are trying to minimize this expression. We are trying to minimize this expression where V is the volume on the link and T is the travel time of the link. So we are trying to minimize the volume into travel time product for each link. Okay, so for example, you want to connect node 1 to all the other nodes. Okay, so from node 1 you can you have every node is available. Okay, so time from node 1 to node 2 is 1 minute, and time from node 1 to node 5 is 2 minutes. Okay, to go from 1 to 2 it will take you 1 minute, and to go from 1 to 5 it will take you 2 minutes. Okay, so from here, if you want to go to node 3, which is connected by node 2, then you will go by this path. You will never take this path. Okay, this is the quickest method, the quickest method. You can look at the procedure here, but I will explain it with an example. Okay, so let's say I want to go from which one? Let's say I want to go from 1 to 2. 1 to 2. No, that's very easy. Let's say I want to go from 1 to 4. 1 to 4. Okay. So 1 to 4 is also very easy. I want to go from 1 to. Let's say I want to go from 1 to 6. 1 to 6. Okay. I want to go from zone 1 to zone 6. Okay. Which path I will take? I can go from 1 to 4 to 6. It will take me how many minutes? 4 minutes. If I go from 1 to 3 to 6, it will take me 3 minutes. 3 minutes. Okay, so this is 4. So I will not go from 1 to 4 to 6. I can go from 1 to 3 to 6 because it takes less time. Is there another path available? Yes, I can go from 1 to 5 to 6. And it will take me 2 plus 3, 5 minutes. So again, cancelled. Okay, 1 to 3 to 6 is still the fastest, quickest. Okay, and is there another method available? Yes, I can go from 1 to 2 to 5 to 6. So it will take me 3 plus 2 plus 3. So 3 plus 2, 5 plus 3, 8. So again, it's not the quickest. So if I want to go from 1 to 6, from all the options available to me, I will take the quickest one. Quickest one is 1, 2, 3 to 6. To go from 1 to 3 to 6. Okay. So this is the explanation, and you can see the paths are given here. Okay, and there if you want to go from 1 to 5, 1 to 6, which path you will take, and so on and so forth. Okay, the paths are given, and the procedure is given here. But basically, from each node to the end node, you will see all the possible paths, and then you will take the one which has the least travel time. This is the main procedure here. Okay. One modification to the minimum path algorithm. Okay, so in the end, if you want the number of trips on each link, now link is connecting two zones, right? Link is connecting two zones. So if somebody wants to go from 3 to 6, he will also use this link, right? Because this is the only link to go from 3 to 6, right? And somebody who wants to go from 1 to 6 will also use this link. So number of trips from 1 to 6 will use this link and this link, and number of trips who go from 3 to 6 will only use this link. So number of trips on this link will be higher as compared to this link. Okay, so number of trips on each link will be the summation of all the people who are using that link. Okay, so if I come here, you can see 1 to 2. People who go from 1 to 2 will use the link 1 to 2. People who are going from 1 to 3 will also use 1 to 2. People who are going from 1 to 4 will also use 1 to 2. Okay, so on link 1 to 2, you will have 50 plus 75 plus 80 trips. Who are these trips? These are the people who want to go from 1 to 2 and 1 to 3 and 1 to 4. All these people will use a common link, so all of them will be added on the link 1 to 2. Okay, and similarly 2 to 3 will be used by these 75 people plus these 60 people, and so on and so forth. So first of all, you find out the quickest path. And then you see on that path how many people want to go. Okay, and one link can be the common link between different zones. So the trips between all those zones will be added to that link. Okay. One modification to a warning here. I will take some extra time because I want to finish this. Okay, and then I want to just discuss the term project presentation for a couple of minutes. Okay, so stay here, please. Okay, one modification to the capacity restraint. The minimum path algorithm is the capacity restraint. Okay, now here we are saying whichever is the quickest path, everybody will take it. But every highway has its own capacity. And when you increase the number of vehicles, the travel time on that highway will increase. So if everybody who is going from 1 to 6 uses this link, then the travel time on this link will not be 2 minutes. It may become 4 minutes. Okay, so these travel times are not constant. And if you reach the capacity of the highway, then they may even become 0. Okay, so this is the modification to the quickest path method, the minimum path algorithm, that you need to consider the capacity as well, and you need to consider the change in travel time. Okay, so let's say this is the initial travel time, and using this travel time, you calculated number of trips on a link equal to V, and the capacity of that link, capacity of that highway is C. Then you should calculate the new travel time as well. The new travel time will be calculated using this equation. Then you should run one more iteration using this travel time. Okay, so these values which I have shown here, once you find out how many trips are going to be on each link, then using these trips you put them as V, and you should know the capacity of the link, and you should recalculate the travel time T, and then you do one more iteration. Okay, when you should stop, because every time you will add new volume, the travel time will change, but there will be a point where you will reach equilibrium. What is equilibrium? When T is almost the same as T naught. Okay, so for example, I use these number of trips, okay, for each link, then I calculate T again for each link. Okay, and the T naught are these values. So let's say for this link, the T naught is 2. The number of trips on this one is, let's say, 100. I put 100 as V here, and whatever the capacity is, I will put it here, and T naught is 2. Now, if T comes out to be 2 again, if T comes out to be 2, which is equal to T naught, then you can stop. If it is close to 2, again you can stop. Okay, and again close meaning if it is within plus minus 5%, you can stop there. Okay, so in minimum path algorithm, you select the quickest path, and on that quickest path, you will put all the trips which are going from that zone to the other zone. Okay, so for example, from 1 to 6, like I said, whoever wants to go from 1 to 6 will use this link and this link. Either they are 100, 200, 300, whatever. Okay, and whoever wants to go from 3 to 6 will use this link. Again, if they are 200, 300, 400, 500, whatever. So from 1 to 3, let's say I have 500 people. Okay, who are going from 1 to 3, and some of them will go from 1 to 3 to 6 as well. Okay, so I have total 500 here. Okay, and on this link, let's say I have 600. Some of them came from 1, and some of them want to go from 3 to 6, or they want to go from 3 to 6 to some place else. Okay, so let's say I have 500 here and 600 here. Okay, so you take the T naught, which is 1 minute, volume will be 500, and capacity, you should know the capacity, and then you put it there in that equation. And then here again, V will be 600, and T naught will be 2 minutes, and then you put it there with the capacity. If you get the same value again, which you put as T naught or close to that value, this means you have reached equilibrium now. This is equilibrium. And this equation is given by US Department of Transportation, US DOT. Okay. The general function. So in this equation, they have already fixed the value of the power 4. That the power of V upon C ratio should be 4. But the general function is that the power can be any value. And again, they are multiplying here with 0.15. US DOT, US Department of Transportation, according to their conditions, have fixed the value of alpha and beta. Okay, this is alpha, the term which I'm multiplying, and beta is the power. So they have fixed it. But the general function is this one. Okay, and again, for US highways, they are saying if you want to use the function for freeways and muddy highways, 2 different types of highways, then the alpha and beta can be changed according to the speed of the highways. Speed of the highways. Again, you need some research for that. I have a senior design project which was done on the on these functions, and I will share it with you on the Blackboard. You can read it in your own time. It was done by senior design students last semester. Okay, so let's say in example 12.16, the volume on link 1 to 5 was 485, and the travel time is 2 minutes. Capacity is 500. Find out the link travel time that should be used for the net traffic assignment generation. That is very easy. Okay, let me put it here. It takes less time. So I want to calculate T here. T naught is 2 minutes. Okay, 1 plus 0.15. So again, I'm using the US DOT rates. Okay, the US DOT values, because I don't know which type of highway is it and the speed. Okay, so volume is 500. No, volume is 485, and this is 500. Okay, to the power 4. Okay, so if I calculate this value, 2 minutes, 1 plus 0.15 into 485 divided by 500 to the power 4, close it, 2.26. So in the new iteration, you should use this travel time to calculate the number of trips. Okay, now if let's say the volume exceeds capacity, if the volume exceeds capacity, what will happen? This ratio will become more than 1. This ratio will become more than 1. Okay, and in that case, then you should stop. You should stop. So this ratio cannot be more than 1. This ratio cannot be more than. If you reach 500, then just use 500 to calculate the travel time. That's it. The remaining number of trips have to go from some other highway. They have to go from some other highway. There is no way you can put a value of more than 500 here. Okay. And then we have again a slight variation which is known as total system cost assignment. In total cost assignment, we are saying the motorist will not choose the route, but the highway authority is choosing the route for him or her. So the highway authority is telling him or forcing him to use a particular route to go from point A to point B. It's not up to his choice completely. Okay. And obviously it is less realistic because you cannot force the drivers to take a particular highway, right? It's not under your control normally. Okay. But there are some procedures where you can dictate their choice. You can send them messages. You can tell them this highway is congested and so on and so forth. You can encourage them, but again, you cannot totally dictate them. Okay. So for example, if you have two zones, 1 and 2, and they have one destination 3, and this is the network. Okay, so if somebody wants to go from 1 to 3, they can either go from 1 to 2 to 3, or they can go from 1 to 3. Okay, and somebody wants to go from 2 to 3, this is the only route available to them. Okay, so if 400 people want to go from 2 to 3, they have to use only this link. So 400 people are on this link already because there is no other link available for them. Okay, if 300 want to go from 1 to 3, so they have two options available to them. They can go from 1 to 2 to 3, or they can go directly from 1 to 3. Okay, so the travel time, for each link is given here. The travel time for each link is given here. Okay, and then you select the volume. You select the volume. Okay, so this is the equation for total system cost assignment. Okay, and then you put the volume. So from 1 to 2, you may have 300 vehicles. Obviously, you can only have 300 vehicles. So you can calculate the travel time for route 1 to 2 if all these 300 people come here. All these 300 people who are going from 1 to 2, they use the link 1 to 2. All these 300 people who want to go from 1 to 3, they use this link. Okay, then what will be the travel time? Okay, so you put 300 here, you will get the travel time. Again, from 2 to 3, the travel time can be different. If all these 300 people who are going from 1 to 3, they go from 1 to 2 to 3, then the volume from 2 to 3 on this link 2 to 3 will be 300 plus 400, 700. Okay, if people who are going from 2 to 3 use this link, so this is 400, and people who want to go from 1 to 3 use this link, then it will be only 400 here and 300 will be here. Okay, and similarly, if all these 300 people who want to go from 1 to 3 use this link, then the volume on this link will be 300. Okay, so using the different volumes, you can calculate the different travel times. Okay, so if you choose equilibrium meaning that people will the total travel time to go from you want to make sure the total travel time to go from 1 to 3 from both is equal. Okay, total travel time to go from 1 to 3 either from this route or this route is equal. So you keep on. So this 300 will be basically divided. You have to select a division of this 300. Okay, so some of them will be on this link, some of them will be here, and some of them will be whoever is here will be added here as well, 2 to 3, and some of them will be here. Out of these 300, some of them will be here and some of them will be here, and whoever is from 1 to 2, he should also be here as well. Okay, so 2 to 3 is 400 plus volume 1 to 2, because whoever is going from 1 to 2, he is going to 3. Okay, so now you have to decide the division of 300 so that the total travel time from 1 to 3 from both routes is equal. So you can see here, 2 to 3. So 400 are going from 2 to 3. Okay, and out of the 300, 132 out of the 300, 132 are using the route 1, 2, and 3, and the remaining 167 are using the route 1, 2, 3 directly. Why? On the basis of travel time. So you see, if I put these values, then the total travel time to go from 1 to 2 to 3 is 12.02, and to go from 1 to 3 directly is also 12.02. So this is equilibrium, that both routes are giving you the same travel time. So the 300 is divided in a manner that the total travel time. So what did they do? They added these two and they put them equal to this one. Okay, travel time, let me write it here. Travel time 1 to 2 plus travel time 2 to 3 equals travel time 1 to 3. Okay, so we already know 2 to 3, volume 2 to 3 equal to what? 100 plus, let's say, x. What is x? People who are going from 1 to 3 using this route. Okay, what is volume 1 to 3? That is x. Sorry, volume 1 to 2, that is x. And what is volume 1 to 3? That is total was 300 minus x. Whoever is remaining will go from 1 to 3. Okay, so now you put all these volumes into these three equations and then you put them here in this equation to get the value of x. So x came out to be 132.73. This is on the choice of the motorists. This is on the choice of the motorists. Okay, let's say the government tells all the cars or all the motorists to go from route 1 to 3. If they have to go to zone 3, they cannot go from 1 to 2 and 2 to 3. Okay, so for example, let's say they block this mode, they block this link by any means. They block this link, so whoever has to go from 1 to 3 can only choose this one. Okay, so 1 to 2 will become 0, 2 to 3 will become 400, and 1 to 3 will become 300. So then the travel time will be this much. Okay, so this is the effect of forcing the travelers to use a particular link. In that case, you may not have the equilibrium, but the total cost of the system will be less. Now you can see travel time of one route 12 minutes, travel time of the other routes is also 12 minutes. Okay, now if you multiply 12 minutes with this one and then 12 minutes with this value and this value, the total cost will be higher. The total travel time for all the routes will be higher. But if you see here, because you see 12 plus 12 is 24, 12 plus 12, 24. But in this case, what will happen when they forced everybody to go from 1 to 3? What happened? This travel time is 12 minutes, and the travel time of the other route from 1 to 2 to 3 is only 9 minutes now. It's only 9 minutes because these 132 people are also going from here. So the travel time of this link reduced, and the travel time of this route remained 12 minutes. Okay, so 12 plus 9 is what now? 12 plus 9 is 21 minutes. So you can see the total travel time of the entire network is reduced. Why? Because the government intervened and that they said you cannot use this link at all. Okay, so this is the thing. This is reducing total system cost assignment. Total system cost assignment meaning you are reducing the total travel time of the entire network, but you have to force the motorists to use a particular route against their choice. Against their choice. This was basically the first table was the choice of the motorist, and the second table is the forced matrix, which is reducing the total system cost, but it is not realistic as I mentioned earlier. Okay. Now, obviously, I did not have the time to do the presentations today. I've already extended the deadline for the assignment. Okay, the term project report. Okay, it is extended till Sunday. You can submit till Sunday. Okay, presentation. When do you want to give the presentation? Tell me. I can take it. Let me tell you, and you can tell me if it suits you. I can take it. If you want to give, first of all, do you want to give it after report submission before? Tell me.
After lecture. Monday.
After, everybody agrees? Everybody agrees after report submission?
No, before, so we know if there is a mistake or something.
Yeah, this was my point. Okay, it was a presentation. If you give the presentation, I will not cut marks for you, even if there's a mistake. Okay, so it will save marks in the report. You want to give before the submission? Tell me.
No problem. Okay.
Ali? Well, Mohammed already left, so whatever you decide, we will just inform him as well.
So no problem.
Before, okay. So before means I think Saturday is fine then, or no? Saturday you
is
have
fine for me.
Saturday you have holiday or what? No, I mean, like, what do you call? Saturday is you know.
It's
You have
fine
work
for me.
on. Sorry.
It's fine for me.
No, I wanted to ask. Do you have work on Saturday or not?
No, we don't have.
You don't have, so we can do it in the morning, right?
Yeah.
Okay, 10 minutes each guy. Okay, so it will not take more than like half an hour for everybody to finish. Okay.
What should we present?
What you have done in the project until now.
Okay,
And
explanation.
including the final everything. Okay, what you have done in the project up to everything. Okay, so even the final stage will be part of the presentation. Okay, the one which you have not submitted yet will be part of the presentation, and if I see any mistake, I will let you know. Okay, so Saturday at 10 a.m.
Okay.
Sayed, Ali?
Yeah, it's okay for me also.
And submission of report Sunday.
Sunday. So you will like 1.5 day, and I think Sunday is also off, right?
Yeah.
So good for you guys.
No, not off.
Not off.
Some of
You should change
things, yes.
the company. Change your job.
I think he's trying already.
He's trying. Okay. Okay. So you go for the interview. You ask them whether you will give me an extra holiday if the the new year comes on Friday or Saturday or not. Okay. Ask them. Okay. So Saturday 10 a.m. Okay.
Okay.
Okay. And I will not wait. Okay. You are there to do the presentations. So if you are not there, I will just switch it off and I will go away. Okay, so better whoever wants to present better be there. Okay, I will not wait for anyone. Clear?
Yeah.
Okay, thank you. And I will post it in the team as well so that Muhammad also knows. Okay. 10-minute presentation, whatever you did from start to end. And again, as I said, if you have any problem with the project, you just let me know, and I can explain to you. Okay, with the software or whatever. I did not get.
Doctor, after finding the utility function for each mode, we should use.
This is the end for you. This is the end for you for the report. Okay, you stop there. You can discuss that this particular variable has positive effect. This one has negative effect. This one has more effect. This one has less effect. Using the coefficients, whichever has higher coefficient has more effect. Lower coefficient, less effect. Positive coefficient, positive effect. Negative coefficient, negative effect. Like I discussed for the logit model, right? Okay.
Yeah. So no need to do the logit model.
Yeah, you don't have to apply the logit model. You don't have to calculate the probabilities. You calculate the utility function, and then the last discussion will be on the coefficient, and that's it.
Okay. Thank you, Rector.
Okay. So, like I said, any problems, let me know. Okay. And one more thing, we have, I don't think we have covered everything in more detail. So the last thing, the trip assignment part. Okay, I will not include any numericals from this part, the trip assignment part. Okay, only the last one. Okay, I will not include any numericals from it in the final exam. Okay, because I should have covered it in more detail. I should have done 1 or 2 examples in the class. So from trip assignment, the last part of the traffic demand modeling, I will not include any numericals in the final exam. Okay, everything else is included. Okay.
The theory of test, the midterm will be included or no?
No.
Okay.
Okay, so theory before midterm not included. The last part, only the last part. Okay, the one which I did in last 15-20 minutes, it is not included. Example, numerical is not included. Theory may still come from trip assignment as well. Okay, any other question? Okay, thank you. Thank you. All the best. And I believe you guys now have to submit the proposal and so on. So my advice is do it as fast as possible. It is taking a lot of time. Like after you submit it, they take a lot of time. So at least you get rid of it as fast as possible. It is for everybody. Safa, Syed, Ali, get rid of the proposals, prepare them as fast as possible. At the start of next semester, submit your proposal. They will take a lot of time. Okay, and it may come back as well and so on and so forth. So, you know, and you have to discuss with the supervisors, and now they are involved starting some new process, and you know, so it's better you do it as fast as possible. So before new restrictions come, new procedures come, you are already your proposal accepted, then it will be good for you. Or even if the new restrictions come, at least you saved some time. Okay, here's my advice. So thank you, and have a nice have a nice year ahead of you. Okay, and I will see you guys on Saturday, inshallah. Assalamu alaikum.